today we're going to continue our geometry review with a discussion about quadrilaterals. So quadrilateral just means a shape with four sides. So that prefix quad means four. So a quadrilateral would have four sides. There's different names we then use to describe quadrilaterals, just like we had different names to describe the different types of triangles. So some names you might hear to describe quadrilaterals would be trapezoid, parallelogram, rectangle, rhombus, square. Those are all just more specific types of the general term quadrilateral. Let's talk about what features it needs to have in order to fit into each of those categories. In order to be called a trapezoid, it needs to have exactly two sides that are parallel. So I need two sides that if I extended them forever and ever and ever, they would never intersect. And then the other two sides are not parallel to that. So you might see a trapezoid looking something like this. We have two sides that if we extend them forever and ever and ever, they're never going to intersect. The other two sides would eventually intersect. Now you could have a trapezoid that looks not as steep, so it might look a little bit more like this. But still, these two sides are angled just slightly, so if we extended them forever and ever and ever and ever, eventually there would be a point where they intersected. A trapezoid only has two sides that are parallel, whereas a parallelogram has opposite sides being parallel. So I would draw one set of parallel sides, and then the other set of sides would also have to be parallel. We could have a longer and skinnier version of this. But the truth remains that the opposite sides, the ones that don't meet at vertices, are parallel. I'm going to skip down here to rhombus because a rhombus has all sides, opposite sides being parallel, just like the parallelogram, but all the sides are also equal in length. So when I draw a rhombus, it has that extra set of rules that the length of this side and this side have to match the length of this side and this side. That's not a perfect looking rhombus because as I look at my sides here, they're a little bit off of what they should be. But these four sides should be congruent in length. They should have the same length. And then the opposite sides, just like the parallelogram, but the opposite sides are parallel. If I go up to a rectangle is again a special case of a parallelogram. So the opposite sides are parallel, and where they meet is a 90-degree angle. So unlike here where I had two acute angles and two obtuse angles, or here where I had two obtuse and two acute angles, in this case, the opposite sides are parallel, just like a parallelogram, but I have this special rule where all the angles are 90. Now, if I mix together a rhombus and a rectangle, I get a square. And I say that because I need the rules from the rectangle and I need the rules from the rhombus. So opposite sides have to be parallel. All sides have to be equal. That's coming in from the rhombus. And all angles have to be 90 degrees. So a square has the most rules out of any of the shapes on the board. So two sets of parallel sides. All those sides are congruent in length, and all those angles are 90 degrees. In your packet today, you have a parallelogram classification page that looks like this. It tells you to look at the quadrilateral if it's classified correctly. So if the name inside matches the shape that it's in, color it green. If it's not, color it orange. Down below, it has three terms, parallelogram, rhombus, and rectangle, and it just asks you to draw one of those. The other thing that I want to talk about in regards to quadrilaterals today is finding the area and the perimeter. All right, so when talking about perimeter, I'm talking about this distance that it takes me to go all the way around the outside of that shape, When I'm talking about area, I'm talking about all the stuff inside. How many square units would fit inside a shape? So for perimeter, when we're talking about rectangles and squares, we have two options. We can either add these two things up, so length plus width, and then we can multiply that by 2, right? Because we would have another one over here and over here. Or I can do length plus width, and just add up the 4 sides. In either case, 3 plus 9 is 12, times 2 is 24. 3 plus 9 is 12, plus 3 is 15, plus 9 is 24. So in either one of those cases, I get the answer to be 24. When I'm talking about perimeter, I'm talking about a linear distance, a line distance. So the unit is just whatever the unit is. So in this case, it's feet. So my unit is feet. When I'm talking about an area for a rectangle or a square, my formula would be length times width, or length times height. So I'm going to multiply the two sides together. This works because if I think about dividing this into 3 this way, so that each row is a 1-foot section, and 9 this way, 1, 2, 3, 4, 5, 6, 8, 9, I would do 3 times 9, which would tell me that there are 27 squares. I know they don't look like squares, but squares within this shape. Remembering that area is thinking about filling in how many squares are in a shape also reminds us that our units on area is units squared, or units with an exponent of 2. In our shape over here, we have a square. So a square that is 4 inches by 4 inches. Again, perimeter, we could think about length plus width times 2, or we could add it all up. Because it's a square, we know it has 4 even sides. We could also just do 4 times the length of one side. We would get 16 units on those lengths is inches. So unit on my answer is also inches. For area, we're going to do length times width. 4 times 4 is 16. But now remember that we're talking about how many squares would fit in this shape. So my units are inches squared. Your digital practice for today is a website that will have you practicing perimeter and area within quadrilaterals, particularly within rectangular quadrilaterals, so rectangles and squares. Your manipulative practice today would be to run through those multiplication flashcards. You can start to see how multiplication comes in all the time when we're talking about things like geometry, but also when we get to other math concepts. So having those down really, really solid will be a great foundation to do the rest of your math work. Good luck.